Today we will learn about irrational numbers, right? So a number small s, we used to denote irrational numbers by small s alphabet, is called irrational if it cannot be written in the form of p by q, where p and q are integers and q is what? The denominator is not equals to 0. Okay, so any number which we cannot denote in the form of p by q is known as irrational number. For example, root 2, root 3, root 5, root 15, pi, minus root 2 by root 3, etc. These all are irrational numbers, and you already have studied these irrational numbers in your previous class, class 9th. Now we will move towards theorem number 1.3. It is very important theorem that it tells us that let p be a prime number. P be a prime number. Prime number, that means any number which has its factors as itself or the number 1. So p will be having any factor like p and 1. So prime numbers are what? Like 2, 3, 5, 7, 13, 11, then 19, 17. These all are prime numbers. So if p divides a square, right, if p, this prime number, divides any number a square, then p will divide a also, where a is any positive integer. So for any positive integer, if prime number divides a square, then p, that prime number, will also divide the number a itself, right? So we will use this theorem in proving the very important, very classic theorem, that is root 2 is irrational, right? From this exercise, one question is compulsorily asked in your board examination, in which they will ask you that prove that root 2 is irrational, or root 3 is irrational, or root 5 is irrational. These are very important questions, and the procedure of solving is the same for all of these. So we prove these by proof of contradiction. It is a like in mathematics we use this concept called proof by contradiction. That is, we will assume that this is suppose root 2, we have to prove that root 2 is irrational, but we will assume that suppose this is rational, then we will solve it, right? And in the end we will get something wrong, so we will say that our assumption that root 2 is rational was wrong, right? Suppose if I say that 0 is equals to 4, right? 0 is equals to 4, whether it is true? No, it is not true. 0 can never be equals to 4. So that is a contradiction, right? So in this particular questions, we use this proof by contradiction to prove it. So let's start. So let us assume that root 2 is rational, right? Suppose we assume that it is not irrational. Suppose we assume that root 2 is rational. So if it is rational, then we know that every rational number we can write in the form of p by q, right? P by q, where p and q are integers and q, the denominator, is not equals to 0. So we can find integers r and s. Here we can take any alphabet. It is depending upon your like choice, right? We suppose we find it, we write here, we get two integers, any integers we have taken, small r and small s, where s is not equals to 0, such that root 2 is equals to r by s, because it is rational number we have assumed, right? So we can write it in the form of r by s, where r and s are integers and s is not equals to 0. S is what? The denominator, right? So again we have written that suppose r and s have a common factor other than 1. Suppose if I write 3 by 6, so it is having common factor other than 1. So what common factor this rational number is having? 3. So we can like cancel the common terms and we will get what? 1 by 2, right? So in the same manner, suppose r and s have common factor other than 1, right? So then we divide the common factor to get root 2 is equals to, suppose, a by b. Now new number we have got now. Earlier we have supposed the number as r by s, right? Now we have got new numbers 1 and 2. So suppose we take this as new alphabets, suppose a and b, right? And a and b are co-prime numbers. A and b are co-prime. That means a and b will not have any factor other than, common factor other than 1, right? So If root 2 is equals to a by b, cross multiply. Cross multiply, that means this b will get here, it is division, so on the left hand side if it will get converted to multiplication. So we will get root 2b is equals to a, right, or b root 2 is equals to a, b into root 2 equals to a. Now squaring both sides and rearranging, we get, now square, if we square b square will be b square, and root 2 square under root 2 square will be 2 equals to a square, right. Suppose we take this equation as equation number 1. So that means 2 divides a square, right. 2 will divide a square also. Why? Because 2b square is equals to a square, no? So that means 2 will divide a square also. Now by theorem 1.3, this theorem what we have studied just now, follows that if 2 is what? 2 is a prime number. 2 is a, what is 2? 2 is a prime number. Why it is a prime number? Because 2 can only be written in the form of 2 into 1, right. So it follows that 2 will divide a also, right. If 2 divides, any prime divides a square, it follows that 2 will divide a also. So that means 2 will divide a also. Now if 2 will divide a, that means we can write a equals to 2c. Why? If any number is divided by 2, suppose any number you say, you tell me that is 10. 10 is divisible by 2, right? 10 is divisible by 2. So we can write 10 is equals to how much? 2 into 5. That means any number we can write here 2 into 5. So that means we can write a is equals to 2 times c, where c is any integer, right. So from theorem what we have got, that 2 divides a. If 2 divides a, that means a is a multiple of 2. A will come in the table of 2. So that means we can write a is equals to 2 times any new integer. Now here we have taken a, b, any integer, other integer we will suppose c. So that means a is equals to 2 times c. Now suppose this equation as 2. From here what we have got, a is equals to 2c, and earlier what we have equation 2b square is equals to a square. From here we will substitute this value of a in equation 1. So what we have got, we will get here 2b square is equals to 2c whole square. In place of a what we have written, 2c whole square. So 2 square is equals to 4 and c square will be c square. So that means this 2 will go here, the relation between 2 and b square is multiplication. So when we will transpose this 2 to the RHS, it will get converted to division. So b square will be equals to 4c square by 2, that is equals to 2c square, right. So this means 2 divides b square, 2 divides b square. So if 2 divides b square, then again by theorem 1.3 what we can say, that 2 divides b also, right. So here we have got that therefore a and b have at least 2 as common factor. Why? Because a is also divisible by 2 and b is also divisible by 2. But here we have what we have, we have taken assumption that a and b are co-prime, that is they are not having any other factor except common factor except 1. But here what we have got, that a and b have at least 2 as a common factor, right. That means we have got a contradiction, that a and b have no other common factor other than 1. That means our assumption that root 2 is rational is false. Hence we can conclude that root 2 is a rational number, right. So hence proved. Like proving all the questions of this type, like root 2, root 3, root 5, 3 plus root 2, any number in which you have to prove that it is irrational number, we will follow this proof by contradiction method, and the steps of this method in each and every question will be same, right. So you have to just understand this memorize this and you have to practice it once, twice, thrice. Okay, so because why? Because this is very important topic and one question is compulsorily asked from this topic. So in mathematics you have to be like proper steps you have to follow, right? All the steps you have to write and you have to memorize all the steps in your mind after understanding the question. Okay, thank you.